Good morning or good afternoon, as the case may be. My name is Sosale Mohana. I'm a maths teacher who has taught maths for over 50 years in 3 continents and 3 countries, like India, in Asia, Kenya in Africa, and England in Europe. I've just retired a couple of years ago, and I thought I should use my experience to record and deliver a number of lessons based on the British curriculum for A-level maths, so the students who want to reinforce their learning can use it. I have a master's in maths, of course, way back in 1969. I completed my master's in maths, and then I did my teacher training in 1974. I've been working since 1969 till 2019, clear 50 years. So I hope these lessons are useful to you, and you're welcome to watch them, and then with each lesson there will always be a document which covers whatever has been done in the lesson, so you could use that perhaps as your own notes, or maybe to go over what has been taught during the lesson. I hope you enjoy the lesson. Hello. Last lesson, remember I told you I'm going to leave the heading as they are because I'm going to continue with it, and I didn't want to write all those things again. In the last lesson, we discussed how to prove the formula for the sum to n terms and took some simple examples. So I just want to do 1 or 2 very interesting examples. The first one is maybe Jack's grandfather or grandmother gives him £10 on his 5th birthday. She then increases her gift by £2 every year. Her gift every year on subsequent birthdays. Jack plans to use the total money he gets on his 18th birthday. Sorry, I need to clarify it. Jack plans to save the gift money every year until the day after his 18th birthday. As he plans to buy a laptop worth at least £350. Will he be able to buy the laptop? That's the question. So, my grandmom, I am Jack. She gives me £10 on my 5th, 12 on my 6th, 14 on my 7th, and so on till I am 18 years old. And then I'm going to save up all that money. I won't spend a single penny. I give it to my mom. At the age of 5, you would. After about 10, 12, you never give it to your mom, will you? Because you want to keep it in your pocket and maybe spend it. But Jack is a good boy. He wants to buy a laptop, the best laptop around. At least 350 pounds he is ready to spend. Beyond that, maybe he might have to scrounge and ask Dad, can you give me more money? Or Mom, please, I've got 350 saved up so you can give me the rest. So, will he be able to save the 350? So that means we must decide whether the total money he has saved after receiving his 18th birthday gift is 350 pounds. Okay? So before I rub this off, I want to write. So in other words, first year. So let me rub off sentence by sentence and write it here. So on his 5th birthday is the first time he gets. So therefore, 5th birthday, first time he gets 10 pounds. On the 6th birthday, he gets 10 plus 2, which is 12 pounds. You don't have to write pounds. And then on the 7th birthday, he gets 12 plus 2, which is 14, and so on and so on. Now comes the question on 18th birthday. So how much does he get on his 18th birthday? So 5 to 18, how many are there? Standard answer, 18 minus 5 is 13. No. When you say 18 minus 5 is 13, the 5 is not counted. So you must add one more. So it is 18 minus 5 is 13, 13 plus 1, 14. So in other words, my A is 10, my D is 2, my N is 14. What is S14? Standard error among students is 5 to 18. So 13 years, 18 minus 5 is 13. So you find for 13. Look, I'll count and show you. Let's count. Ready? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 4 plus 10, 14 years, not 13. Be careful. So what is S14? We have all the things, so I can find S14 now. So S14 will be S14 equal to N over 2 times 2A plus N minus 1 times D. So 7 times 20 plus 26. 46 times 7. 7 6 are 42. 4. 7 4 are 28 plus 4. 32. Ah, poor boy. So now he has to now beg mom or go to grandmom and say, look grandmom, last month, can you give me 18 pounds more please? I'm sorry, 28 pounds more please. Please, 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 grand. You do it, don't you? But not at the age of 18, but when you're about 9 or 10 or 11, that's all grands are for. I mean, I was not fortunate enough to be pampered by my grandparents, because by the time I was born, 3 out of 4 grandparents were gone. And the other one was pretty old, and my grandfather was a terror. Anyway, but otherwise, generally, grandparents, I spoil my grandchildren. So I'm sure your grandparents will have spoiled you, most of you. So 322, that means he has not saved enough to buy the laptop. So even small things like this in life you can use. But the next one is very, very important, very nice. This is a nice question. Find part A. The sum of all integers between 1 and 300 inclusive, that are, oh, let's put this as this, that are, na part A, divisible by 3. Part B, divisible by 4, okay, and then hence find the sum of all integers between 1 and 300 inclusive that are not divisible by either 3 or 4. So that means I am looking at 1 and 2, 5 and 6, 5, 6, 7, 8 is not included, 9 is not included, 10, 11, 12 is not included, 13, 14, 15 is not included, 16 is not included. Do you understand what I am talking? So I hope you now know this formula, because I have to rub it off, because this question I can't rub and do it. So let's look at this. What are the numbers? Look, I am interested in numbers that are divisible by 3 between 1 and 100. So 1, 2, 3, 4, 5, 6, etc. Then 300, 299, 298, 297, and so on and so on and so on. Okay. Now I want, part A says sum of all numbers divisible by 3. So 3 plus 6 plus 9 plus 12, etc. plus 300, because 300 is included. So therefore, let's call this as S3. Your A is 3, your D is 3, your UN is 300. You find what is N, you find what is Sn. So UN equal to A plus N minus 1D. So 300 equal to 3 plus N minus 1 times 3. Here I'll divide throughout by 3. 100 equal to 1 plus N minus 1. So N equal to 100. 1, alright? So there are 100 terms. So once you have that, let me call this as sum of numbers divisible by 3. Sum of numbers divisible by 3 will be N over 2 times first term is 3, last term is 300. So 303 times 50. What's 303 times 50? I'll put the 0, 5 3s are 15, 5 0 1, 1 5 1 5 0. So the answer for this, let me use a different color, is 1 5 1 5 0. Alright? Good. Now, I want to do the same thing for 4 now. I could have taken 6. I could have taken 7. I just made up the question, so don't worry. So part B, 4. 4, 8, 12, 16, etc. 300. So your A is 4, D is 4, UN is 300. What is N? What is Sn? So UN equal to A plus N minus 1D. All of them go by 4. So 75 equal to 1 plus N minus 1. So N is 75. So there are 75 terms between 4 and 300 inclusive. So what is S4 will be N over 2 times A plus N minus 1D. Sorry, first term plus last term. So A plus L. So that is 75 over 2 times 304. So 75 times 152. Could somebody work out what is 152 times 75? Let me just work out here. It's easier for me to work out here. 7, 4, 4. Okay. 75 times 152 is 26. Oh, no. 75 times, can't see. 152. Is it 152? Yeah. Equal to 11,400. Let me write that in red. 11,400. Now, what is this guy asking in the next part? The next part is interesting. So, what you do is, you got this series 1 plus 2 plus 3 plus 4 plus etc. plus 299 plus 300. Let me write one more, 298, or let me write some more. 1 plus 2 plus 3 plus 4 plus 5, etc. Plus 6, etc., etc. plus 7 plus 8 plus 9 plus 10, etc., etc., etc. plus 292, 296 plus 297 plus 298 plus 299 plus 300. From that, if I remove all the things with 3, if I remove all the things with 4, I will be able to get this, isn't it? So, in other words, I now have to, so what is S of all? A is 1, D is 1, N is 300. So, N over 2 times A plus L. So, 300. So, that will be 150 times 301. 150 plus 301. Let me add this. Oh, sorry, multiply. $150 times 301 is 45,150. So when you add all these numbers, I get 45,150. When I take away 15,150, I have removed all the numbers that are divisible by 3. When I take away 1140, 400, I have removed all numbers by 4. So therefore, not divisible by either 3 or 4. Will be 45,150 minus 15,150 plus 11,400. Very nice. If you do this in the exam, you will lose at least 2 marks. Let me write the answer and then I'll show you why. In the meantime, you can think, why is it that answer is wrong? If you can figure that out, you're a very clever student and you're on the right track. Minus, open bracket, 15,150 plus 11,400. 18,600. The answer is more than 18,600. Have you figured out why? I will show you. When you removed multiples of 3, you removed 3, 6, 9, 12, 15, 18, 21, 24. Hope you are listening. 27, 30, 33, 36. When you removed 4, 4, 8, 12, already removed once, I am removing it again. 15, 16, 20, 24, I had removed it under 3, I am removing it again under 4. 28, 32, 36, I had removed under 3. That means all the multiples of 12, I am removing twice. When you did the multiples of 3, you already removed the multiples of 12. But now you are again removing it. That means you need to add plus sum of multiples of 12. This is a common error. So you need to add, that's plus something. So what are sum of multiples of 12? I'll have to do that again. So now I don't need this question. Remember, so whenever you got 2 different digits, you're going to remove the 3 times 4 is 12, the common divide LCM. you have to make sure you add the sum of the numbers that are divisible by the LCM once, because you will have removed those numbers twice, as I explained. So therefore, the first number is 12 plus 24 plus 36 plus etc. 300 goes by 12. That's why I took that. It's easier. So A is 12, D is 12, UN is 300. So 300 equal to A plus N minus 1 D divided by 12. 12 2s are 24, 25 equal to 1 plus N minus 1, N is 25. So what is S25? 25 over 2 times first term plus last term. So 25 times 312 divided by 2 is 156. Now, you can use a calculator, but have you thought of it? When you multiply by 25, multiply by 100, divide by 4. I find it easier. So it's 15600 divided by 4. 4 3s are 12, 336, 3900. So it is 18,600 plus 3,900. 0, 0, 15, 1, 8 plus 3, 11 plus 1, 12, 1. So it is 22,500. You understand the logic there? Because you remove the 12, the sum of 12 twice, you have to add it. Arithmetic series questions are comparatively easier. In the geometric series, which is a bit of a nuisance. So in the next lesson, I'll take up geometric series and take you through some examples and some more applications which you will see. Thank you very much. Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.